like terms. Today we're going to be able to determine if things are like terms, so whether or not they go together, and we'll continue to add and subtract our integers, which we have been doing. Our vocabulary today are like terms and coefficient, which we did on that foldable. We did the coefficient. Remember, that's the number next to the variable, so 3x. 3 is that coefficient. We'll talk more about like terms in just a moment. Okay, so first question is, how many squares do Teresa and Abdi have together? So if I look at squares, Teresa has 1, 2. So Teresa had 2. Abdi has 1, 2, 3, 4. So 2 plus 4 is 6. So they have 6 squares together. So use the variables to show the addition. Well, if we had s and s for squares, that'd be 2s. So we took Teresa's. Abdi had 4 of them. 1, 2, 3, 4. We're putting them together, so we're adding, so that'd be 4 of them. So 2s plus 4s. So 2 squares plus 4 squares would be 6 squares. That's really all we're doing today. Okay, but rather than pairing it with the idea of a square, we're just using variables. Okay, so we're going to determine if the following are like terms. So like terms means, do they have the exact same variable part? I think this is supposed to say do the terms, not they. So cross out the y there. Do the terms have the exact same variable part? So here my variable part is x. I'm going to use my highlighter. So if you want to use your highlighter, that might be helpful. So this x and this y, they are not the same. X is different than y, so our answer is no. Okay. In the next problem, I have an x here and an x here. But the middle problem doesn't have any variables, so they're not the same. It's not the same variable part. So again, that's a no. So look at each of these terms. There's 3 terms in this next one. The variable with the term is w, w, w. So those are all the same. So our answer for that one would be yes. Those are like terms. Next one, I'm going to go down this time. I have a, b are the variable parts. This one is just a, just b, and ab. So do they all have exactly the same? That means it has to be identical. It has to be 100% the same. So if I have ab, a, b, ab, the answer is no. So they would all have to be ab. Next one, I have 3xy, negative 5xy, and xy. Those are 3 different terms. And this last one, if I need a number, I'm going to put a number 1. I'm making a video. I can't help.
You said us.
I'm making a video. I'm recording. I'll be with you in a second. Okay, so if I have 3 negative 5xy, 1xy, xy is the variable on each of those parts. So the answer would be yes. Okay, so now create your own. So let's do like 2d, 5d, negative 6d. Anything that has that same variable part as long as they all match. That's what like terms are, when they all have the same exact variable part. Okay, so for number 2, we're going to simplify the following expressions. If it's already simplified, we'll write simplified. So first thing we're going to do is identify like terms. So in this problem, I have a w and a w. So because this variable is w, w, these are like terms, which means I'm going to actually add them together. So we use our integer operations to combine coefficients. So our coefficients are the numbers next to the letters. So we're going to do 12 plus 9. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21, and then we keep the w. So if I had 12 w's plus 9 more w's, I would end up with 12 w's. Okay, and the next one, I have a k here and a k here. Those are the variables. No k on the 8. So the only two things to combine are these first two. And what I'm thinking is, what is negative 17 plus 5? Well, they're different, so because they're different, we're actually going to subtract. So 17 minus 5. 7 minus 5 is 2, carry the 1. So that would be 12. Do I have more positives or more negatives? I have more negatives, so it would be negative 12. And then we keep the k, because we're counting k's. So negative 12k. And then this minus 8 just gets tacked on at the end. Minus 8. That's a weird minus there, but that's okay. And that would be our answer. Okay, 2 more and then we're done today. So we have an AB here. AB. AB. Now I'm not going to highlight this last one because it's not exactly the same. It's only an A. All right, so I'm going to combine these three. So I'm really doing 32 minus 4 plus 6. So 32 minus 4 would be 31, 30, 29, 28. So it would be 28 plus 6. 28 plus 6, right? 29, 30, 31, 32, 33, 34. So 34, the variable part was AB. Now this plus 9a just sneaks in at the end. Plus 9a. And that is it. We can't combine those two. They are not like terms. Because this one is counting a's and this one is counting ab's. All right, last one. All right, here I have an A. Oh, I don't see any other A's though, so I'm going to switch my color. Next I see I have a B. Oh, here's a B. And then we have a G. That's a completely different color. So that's a different variable. So the only ones I can combine here are the B's. So I'm thinking of the coefficients 8 minus 15. And I'm going to change it to adding the opposite. So I'm going to have 8. I'm going to change the subtracting to adding. And the opposite of a positive 15 would be a negative 15. So now I think that they're different symbols. So if they're different symbols, I subtract. 15 minus 8, I know that's 7. And I have 8 positives, and I have 15 negatives, so more negatives. So negative 7b. And then I carry down the other parts. That's really important. So I still have 5a plus negative 7b plus 13g. All right, last one is the summary is like terms. What are like terms? Give me an example, write it in words. How do you know if two things are like terms? And that is it.